Hello everyone, welcome to Go Back the online course Data Science. Today talking about prediction. And in this video, talking about how to use the scikit-learn to run the prediction. That is, we want to training the prediction with scikit-learn. We can keep the data from we use the data set as our training data. Okay, the iris data we three of iris setose iris, color, and virginica. We have three kinds of iris. We will receive iris data some CSV file, and from scikit-learn, we can import the data set from internet. Our database contain the iris data set. The iris data set is very important, so the iris data set is included in the scikit-learn. So here we use this method to read the iris data. From scikit-learn, we can import data set and use the instruction load iris. We can load iris data set, and because we need process in NumPy, okay, to prevent the duplicate or numerical access about the data, so we must import by SNP. And when we load the iris data, okay, when we load the iris data, we give the iris data in the iris. Then here, the iris is the two part. Iris, this object has two part. Data and the target. Data is here, this part, and target is the class label about the target. So we need to let the iris data have four features. But now we need to apply the result of iris data in two dimensions. Okay, so we just select two features as our the feature of training data. So we just select column 2 and column 3, or column 0, column 1, column 2, column 3. We just select column 2 and column 3, and we consider all the rows. Okay, so this X is the training data. Okay, just consider petal length and petal width. For the iris, the target just select label. Okay, so for this kind of data, we have two parts. One is data and one is target. And however, for the other kind of CSV file, the definition may be not different. So you must to understand the format about the definition of the file. Okay, so at first we must apply the data into several training and test data, and randomly select some portion of the data to training and testing. So we can just use training test sprite. Okay, for scikit-learn model, we selection import training test sprite. We use the training test sprite to divide original data into training and test. So we can specify test size 0.3. That is, for the data, 0.7 be training data and 0.3 be testing data. We just use this instruction to divide the data. And when we have data, we must do this standardization. What is standardization? We must to initialize a new standardization object. So from the scikit-learn processing, in pre-processing, import standardization scalar. That is how to make pre-processing. That is maybe some features with larger number and maybe some feature with smaller number. So when we calculate the weighted sum, then the larger number will dominate some smaller number. So we must transform all the field to the standard normal distribution. Transfer the original data into standard normal distribution. We use standard scalar. So standard scalar, the first method is fit. We use fit to estimate the parameter mu and sigma. Okay, and then when the mu and sigma is calculated for each feature, we can use standardization training data. We can use this object to standardize the training data, and the testing data use those same parameter. Okay, so fit, we have the parameter about the mu and the sigma for each column. We can transform that we transform the original distribution from each column to the standard normal distribution. Okay, And we use the same mu and schema to transform the testing data to standard normal distribution. And we can train a projection model that's a simple instruction. And here, scikit-learn by the multiple label classification. The multiple label classification used in scikit-learn is one versus rest. So we can allow us to feed 3 flowers cases precision at one time with one case. Okay, so we can import scikit-learn linear model is precision. Here we import the model precision from the scikit-learn. That is, you don't need to write the precision program by yourself. You just use the model from the scikit-learn model to import the precision. And this is now we import the package precision, and then we generate an object of precision, give the parameters eta. Okay, what the eta learning rate, what the rate, and the random state. Random state, that is precision. We must give the initial. How to generate initial rate? Sometimes we can we can generate the initial rate use random number. So for the random number, we must assign the random state. Random state is the random state about the random number. So here we precision. We control precision is eta and the random state. In the fit we train the precision. Okay, we have a precision, and we train the precision. How to train the precision? Use the data and the label. Okay, data. We use what data? Train the transform data, standardization data, and here y is label corresponding data. Okay, so we just use the single instruction to train precision. We don't need to write code about precision. We just very easy. We just use the code, this instruction, train the precision. When we have a precision, we may make this prediction. How to make the prediction? We just use the result. Okay, the x the result. Okay, to make the prediction. Okay. Now we have a prediction, the object prediction, and we give testing data. So what is testing data? This testing data is X test standardization. This part we have a 0.3 of original data as training data. Testing data. Feed the training data to the projection, and the projection make prediction on the training data and get result Y predict. Okay, when we have Y predict, we can compare the Y test and the Y predict. Okay, Y predict is the Y head. What is Y head? The predict result by the projection. And the Y test is Y original in the testing data. Okay, the correct label. And we compare, is this different than this mistake, and we'll return 1. Otherwise, it's correct, we return 0. So we can calculate the sum. What is the sum? Then we're counting how many number of mistakes in this prediction. Because the iris data not linear separable, so the prediction will make mistake. Okay, so the result is we find 1 mistake out of 45 hours. So approximately misapplication error on the test data is approximately 0.0. Accuracy, we can use another measurement to calculate accuracy. That is, accuracy. The problem of error is accuracy. 1 minus error. Okay, the 1 minus error, we can use this instruction to calculate the accuracy. Okay, from scikit-learn we import accuracy score. We can just use this instruction to calculate the accuracy. So now the accuracy is 0.978. And the other, we can plot the region. Okay, we can plot the decision region based on the weight, the rule about the hypothesis or the rule of the model the data. Okay, we can like to divide original into 3 regions. Okay, also for each region corresponding to class of iris. So we can plot the region use different color. And for the training data, we can plot the point, the training plane. Okay, another is testing data. So here you can see the third class 0 almost the data is correct, but here is mistake because this data is S1. And for class 2, okay, we have a several mistake. Okay, so we can plot. We have a control model. We control a model, the perceptual control model. Let's say we have a linear. We have a line, several lines to divide the original into 0 position, and we can use the math paradigm to plot the region belong to some classes one color. Okay, and then we can plot the data. The data contain training data and net data. Okay, so here training data. Here this point is testing data, and this point is training data. Okay, we can plot all the data in the plane, and we can see the correctness about the data. Okay, so this is a method for visualization, or for visualization. So we can use this to plot the disease region, and we can see the performance. Okay, by visualization you can understand the performance. Okay, it's easier to understand. But here, just consider the perception as two-dimensional. However, the perception may be very high-dimensional. So here we just consider two-dimensional perception, and we can use the plot about the digital region to understand the performance of our perception of our model.